Canoe Lab Report.
Aaron Alec, Justin Anko, Marissa Bieber, Bridget Harkins.
Lansdale Catholic High School.
First period.
So, Bridie, who is Archimedes?
Archimedes was an ancient Greek physicist and mathematician that came up with Archimedes' principle, which indicates that the upward buoyant force that is exerted on a body immersed in a fluid, whether fully or partially submerged, is equal to the weight of the fluid that the body displaces.
So Marissa, what is buoyancy?
Buoyancy is an upward force exerted by a fluid that opposes the weight of an immersed object.
So we've been working on a cardboard canoe in our physics class lately. How does this principle relate to the cardboard canoe?
So, an object whose density is greater than that of the fluid in which it is submerged tends to sink, and if the object is either less dense than the liquid or is shaped appropriately, the force can keep the object afloat. So some boats sink and some boats float.
Objectives.
Build a canoe that holds 2 people whose weight add up to 275 pounds.
Construct the canoe out of cardboard and duct tape and make sure it floats.
Have the canoe travel 50 yards and try to be the fastest.
Procedure.
Okay, so we took a cardboard box from old cabinets and we used that as our base where the 2 people sat, and then we put triangles on the side for support so it wouldn't sink.
And then we covered the canoe in duct tape so that it would float and stay together. And we also made a paddle so that the 2 people going in the boat could move forward. So we made the paddle out of more cardboard and more duct tape.
So we lined the whole bottom of the canoe and the paddles in duct tape because the duct tape was more water resistant and the water from the pool wouldn't saturate the cardboard and cause it to sink.
And then after we covered it in duct tape, we then decorated it as the theme.
After the construction of the canoe, it was placed in the pool at the Y in Lansdale.
Then 2 people got into the canoe and raced in the pool 25 yards up and 25
As
yards
the canoe
back.
was racing, one group member was recording the time and the other was videotaping the race.
Materials.
Duct tape
Cardboard
and the pool at the Y.
and also markers for decorating.
The distance that was supposed to be traveled was 50 yards, but we only traveled 25 yards, which was one length of the pool, and that is equal to 22.86
And the reason we
meters.
didn't get all the way was because it was hard to balance on the canoe and we tipped over, and that's why our time also slowed.
The time for going 25 yards was 2 minutes and 31.02 seconds, and then we had to calculate the velocity at which we traveled. So the equation for that is v equals delta x divided by delta t. So the delta x was 25 yards, which we had to convert to meters, and that came out to 22.86 meters. And then you divided it by the time, and we had to change minutes to seconds. So that came out to 151.02 seconds. And when you divided those two numbers, it was 0.15 meters per second, so velocity was 0.15 meters per second.
Mass of each person in the canoe. I weighed 165 pounds.
And I weighed 115 pounds, and that adds up to 275 pounds. When you convert that to kilograms, it's 124. And then the mass of our canoe is 65 pounds, and then convert that to kilograms, and it's 29 kilograms. And then the combined mass of us and the canoe was 153 kilograms, and that was going a 25-yard distance. The buoyant force, the equation for that is FB equals mg, and then m is the mass of the canoe and us in it, and g is the gravitational force. So m was equal to 153 kilograms, and then g was equal to 9.81. And then when you multiply those two together, you got 1,500.93 newtons.
Conclusion. Our original hypothesis going into the boat is buoyant, then the boat would make it 25 yards down the pool and 25 yards back.
However, we proved that this was not true. The two group members really struggled getting into the boat, and once they were in it, they had a hard time balancing, and the boat was so buoyant that they weren't able to use their hands as paddles. So they eventually ended up tipping and having to...
The velocity that we calculated was v equals delta x divided by delta t, and that came out to 0.15 meters per second. And this was relatively slow velocity, and this is because we couldn't balance on it and somebody lost the oars.
Another reason is because we also got water into
We did
the
not meet the
canoe.
objective of building a boat that could make it 25 yards down and 25 yards back in the pool, and we also didn't meet the objective of trying to be the fastest boat in the pool.
However, we did meet the objective of constructing a boat that would hold 275 pounds. However, the canoe was too buoyant.
Our group had trouble putting the boat into the pool especially when the group members got in, they had trouble balancing, and it was because the boat itself was too buoyant and didn't go down far enough to hold the weight on both sides.
Explanation of this.
Okay, so the velocity that we, the equation that we used is v equals delta x divided by delta t. And that came out to 0.15 meters per second. And this was a relatively slow velocity, mainly because we couldn't balance, so our boat was tilting back and forth. And because somebody lost our oars, so we didn't have anybody paddle it.
And also another thing that slowed us down was the water seeping into the canoe, like, because it was tipping over, so there was water getting in and it was making it heavier. So that slowed us down a lot also.